So there are all sorts of flowcharting programs you can use. If you have a one of those Microsoft Surfaces where you like to, touch the screen of your laptop, then the one that I'm about to show you isn't the absolute best solution. If you have Microsoft Office installed, there's one called Visio, V-I-S-I-O. I show everyone this one called Lucidchart because it's, cross-platform, whether, you have Mac, PC, Windows, Linux, whatever, you can get it to work. That's the one that I use in here, so that's the one I will demonstrate. You're free to find another one and use it. So what is a flowchart? A flowchart is a series of symbols representing logic. But it needs to be set up very specifically for it to work correctly. Here, let's look at this one, and then I'm going to say that it doesn't really look like the one that I would want to use. Oh, cool. Ah, come on. Take me to a good example. There's one. They all start off with an oval called a terminator. Then they have some square boxes. They have tilted rectangle boxes, which this one isn't showing. I mean, rectangles, and you could give a fancier name to the tilted ones, quadrilaterals or whatever you wanted to call them, but technically rectangles are quadrilaterals. Then it's got these diamonds. Diamonds are decisions, like if statements. Is this valid? Yes, to do something. No, do something else. This isn't going to look exactly like ours looks like. We will do some examples of our own. So to get these going, we need some kind of some code or some kind of pseudocode to work with. So I'm going to go ahead and load up idle, and we'll do another pseudocode example just so that we have something to flowchart. So I did new file. I'm going to do a save as. I don't remember what lecture we're on. D?
No, E.
E? All righty. All right, so I'm going to put my name up at the top. Put the date up here. Guess I don't have to write the word date, huh? I know that's what it is by seeing it. All right, I would like for y'all, I mean, on the in-class assignments, it doesn't really matter whether you type in the comments or not, but when you're writing Python code to submit as homework, please go ahead and add comments. All right, so what is this program going to do? How about it convert from Fahrenheit to Celsius and then say whether it's freezing or not? So convert from F to C and then display if it's freezing or not. That's going to be a little bit more. These would be a little bit better than that. That's not enough to write a program by. Or, yeah, I could tell you to do that, and you could go off and interpret it your own way. But as far as creating the logic, the algorithm, the recipe, I'm going to go back to the triple quotes because since this is pseudocode, it would not compile. So, start. All pseudocode starts with start. How about I add the idea that this is pseudocode? So start, we better get the temperature F. So how about print, parentheses, nope, I'm slipping into Python, not pseudocode. Output, what is the temp in F, question mark. And then input F. I don't care if you did it lowercase, uppercase. Don't know what's wrong with my voice. All right, then we need to do our formula. You know, I could put all this extra information up here. You know, if I was giving this to you as an assignment, I might give you the equation, I might give you the specification for whether something is freezing or not. So I might say formula C is equal to F minus 32 divided by 1.8. Something like that. That's the formula. Except I put the parentheses in the wrong place. Forgive me. Parentheses goes before the slash. And freezing is C below 0. I'm documenting it. Even if I wasn't going to write the pseudocode, this would be good stuff to put in the comments. Now we might take the time to go ahead and write this in Python as well before we do the flowcharting. Or maybe we'll do the flowchart and then the Python. Haven't decided yet. But our programs are generally going to be of the step of, at least these first ones, input, calculate, output. Well, we've got the input, right? Now we need to do the calculation. Set C equals, and then I'm just going to copy that equation. Parentheses F minus 32 into parentheses slash 1.8. All right, we've got the temperature. Now we need to decide whether we're going to print whether it's freezing or not. So if C, now I could write it out, is less than 0, but, you know, we're all grown-ups, we know what the less than sign means. So if C less than 0, I wouldn't count you off if you put a colon there, because you do put a colon there when you're writing Python, right? And then I'm going to output, quote, freezing, exclamation point, end quote. Else, and I back tabbed, right? Because that else needs to be lined up with the if statement. Output, not freezing, exclamation mark, end quote. And although there's certainly no such thing as an ENDIF statement in Python, I'm going to go ahead and put it in our pseudocode. Forgive me, I'm going to go and Google to see if that's standard practice or if that's something I made up. I'm sure we'll see it in our... how come you won't... Windows is supposed to get smaller than that. Oh, come on. Why is it forcing itself to fill up half the screen? Never seen the like. So I'm just going to Google up ENDIF pseudocode. Except I'm using IE and it's already hung. There we go. That didn't work. Google.com. I'm regretting not being able to use Chrome, but it was filling up more than half the page. ENDIF pseudocode. Yeah, I like that. If something else something. You'll notice that this pseudocode example, from whatever university this is, University of Florida or something, they're using the word print. They're capitalizing the first letter of every line. They're not sticking things with a start and a stop. Our book shows us not doing all of that, right? Our book shows us using lowercase, I believe. and prefixing, you know, it with a start, putting a stop at the end, and putting an output. Just showing that pseudocode is a loosey-goosey thing. It's not an actual programming language. All right, and then finally I need to do a stop. So I'm going to backspace all the way to stop. Back tab one more. That's our program. Well, that's our pseudocode. That's the logic. That's the algorithm. But we're going to represent that in graphical form. Pictures are worth 1,000 words sometimes. Sometimes they take 1,000 times longer to draw. But let's give it a shot. So I'm going to go to Lucidchartcom, and I'm going to sign in with my Raider Rose email address. So Lucid, L-U-C-I-D, chart, C-H-A-R-T.com. Sign up with Google. I'm going to see if I can log in with a different email address. Just so I'm logging in with a new account. Make it look like yours. Good, I'm going to try. Alrighty. Annual subscription. Start free account. Now every year it seems like they change the terms of the free account. They used to have an educational one, then they removed the educational one. They did a a free account, but it was limited in the number of things you could save or print. Right now, I don't think any of that is true. I think that there's no limits on the free account. And it starts asking you all sorts of annoying questions. Tell us about yourself. Is this blurry? I may regret messing with these. Well, it sure is shaky. I pity y'all having to look at it. I'm sorry about that. All righty. So, I am a student, home or personal, whatever. I don't really think it matters. Click the close box. All right. Hopefully you're at this point. I'm going to go kind of slowly, and I'll leave the flowchart up or print it out or whatever in case you don't, get it all entered. So I'm going to hit the plus sign. I'm going to make a new document. Blank document. Then it starts giving me hints. Well, I'm so cool, I'm going to skip the hints, but you might want to look at them. I don't know. Well, we may as well look at them. Yeah, we're drawing things. We're hooking lines up, right? We can see. I can show you better than this. Yeah, you can change the color of things. Yeah. Skip all this. Okay. All right. So I'm just going to totally mess around at first. I'm not going to draw any specific logic. I'm going to grab the oval, plop it down. Notice that there's these edges. You could resize it if you wanted to. I go to a lot of effort to try to make things as small and tightly compressed, compact on the screen as possible. You don't need to do that, right? Because you're not trying to squeeze as much onto the screen as possible, like I do. I wouldn't bother, if I wasn't trying to, put it on the screen for a projector. All right, and then you notice that as you move your mouse closer to a shape, your cursor turns into a crosshairs, and you can click and drag and get an arrow. Now, honestly, that's not usually the way I do it. But if I do that, it comes up with another menu of shapes. I'm just picking these shapes at random. What I normally do is I draw a box, a second box, and then I hook them up, right? I come up here and I click and drag to get the arrow like that. So there are some general rules for drawing flowcharts. One is that every box has to, no matter what the shape is, every shape has to have one line going away from it, except for the diamond, which has to have exactly 2 lines going away from it. If you do more than that, if you have this one going off there, and you also have a line coming from here to here, or whatever, then it's not correct. And by not correct, I mean you won't get full credit for it, which is a drag if I make you draw an flowchart on an exam. I wouldn't make you draw a big one, right, because we have limited time during our exams, you know, and I wouldn't give you something that took 2 hours to draw for something you're supposed to get done in an hour exam. But anyways, so one line going away from every shape except for the diamond, the decision, and that one gets exactly 2. And every decision is a yes or a no, right? If I'm hungry, I go eat, else I don't. There's no third state. A decision can be one of a couple of different concepts. It could be an if statement, or it could be part of a loop. Now the textbook will show you using the same shape and the same wording for both. I'm very particular about how I want you to do your loops. On the other hand, if you do them the way that the book shows, you're not going to get counted off, right? That'd be kind of jerky of me. But I'm going to show you what I think is a better way. Alrighty, now I'm just going to delete all that stuff because, well, maybe not quite yet. I'm going to say I drew that and then I think that that's not right. I need to change the shape of it. Yeah, I could delete it, drag another box out, but instead I'm going to right click on the shape and do change shape. You see that? You can right click on any of these guys and do change shape. And then you can pick the shape that you really wanted it to be. There's the infamous tilted rectangle, quadrilateral. Hate that term because the diamond's a quadrilateral too. Maybe the book has a better term for it, I don't recall. So, these all have meanings. This is a terminator. It's either for the word start or stop. This is a decision, which for now is going to be an if statement. Then that is for input and output, like input and print statements. I'm going to go ahead and add that there, but I'm going to wind up deleting all this stuff in just a minute, so you don't need to. And then process, that's a mathematical calculation. The shapes all mean something very specific. So if you put your print statements in square boxes, points off. I didn't invent these. These kind of actually predate programming. Then, you know, if you put an if statement inside a tilted rectangle, it's not right. If you forget to put your start and your stop ovals on it, it's not right. So we want to try to get it right. We won't be drawing a whole bunch of these, but we got to get the idea that you can represent logic. All right, as promised, I'm going to delete the whole thing. If you're so proud of your work, you want to keep it, just scroll down to another area. I would like to be able to see the pseudocode that I was working on. And then it becomes a problem, well, I fill up half of that page with that, and I fill up half of this with that, and I'm getting it, you know, it's not letting me do half and half. So all I'm going to do is I'm going to actually copy my pseudocode. Now you don't have to do this, but I greatly appreciate it if you do, when I ask you to draw a flow chart as homework, that you put your pseudocode on it as well. So I'm just going to highlight all that, right click, copy, come over here. Now I need a box to put this code in. This T looks plausible, the text, but I'm going to go ahead and grab this top box up here and just drag it out, double click so that I'm editing the text, and paste. Now that's not too hot looking actually, right? It's all centered and stuff, and code's not supposed to be centered. So I'm going to change the margins, right? The alignment. I don't want it to be centered. So I'm going to come up here under alignment and say that I want it to be left justified. Now it's looking better. And you can take a huge amount of time to make this stuff look the way you want, right? You could highlight it all, you could pick a different font, whatever. I'm just using this as a reminder for what I'm about to do, so I'm not going to put a lot of effort into making it look any particular way. If you like changing the colors of the blocks, you can do that. Now there's only one specific point where I actually color the blocks in a very specific way, and you don't have to do it that way. If you feel like being artistic and making every single block a different color, we'll get to the point where I actually use color for a very specific purpose. You won't have to do that. It just does make it easier to read at that point. All right, so start. I need a terminator. Start. I wouldn't count you off if you said begin rather than start, but whatever. I'm going to shrink it down. You don't need to do that. In fact, I'm going to go into full screen mode if I can. That makes things harder to see, but I have more screen real estate to play with. To zoom in, you hold the control key and you spin the mouse wheel. If you need to move around the page, hold the space bar down and then move the cursor. So you can pretty much get to wherever you need to. There are times when I will zoom all the way in, and I'll show you when that might be. Don't draw what I'm about to draw, because I'm going to delete it. But when you put things so close together that it's hard to maneuver things around, right? Then it can be very useful to zoom way in, and then you can grab the points that you're trying to grab, right? Whereas otherwise it's impossible when it's the shapes are that closely tied together. Alrighty, so output. As mentioned, output statements are done in the tilted rectangles, otherwise known as the data blocks. There we go. So I'm going to click and drag. And then I'm going to double click. Output, quote, what is the temp in F, question mark, end quote. Now if you don't like the way it broke the text up, right, where it went to the next line, you can embed a hard return. What do I mean by that? What if I wanted a return right there? Well, if I just move my cursor there and hit enter, it doesn't do anything. But if I come back in and move my cursor there and hit control enter, it puts a line feed there, it puts a character turn there. So if you want to, you can mess, with getting the writing to fit inside the box. Now that I've added those things, it's still going to kind of mess up if I shrink it. If you're under time pressure, like during a quiz or something, don't take the time to make things pretty, unless you have time at the end of the exam or whatever. All right, then I need to draw an arrow. Now, which way do I draw the arrows? Well, it always goes from the prior line of logic to the next line of logic. Generally, flowcharts are drawn top down. But since we have these arrows, technically you could draw, like this. You could make the boxes go anywhere you wanted to, as long as the arrows were correct. I'm going to give you credit for it. Right? This isn't an art class. I'm not going to, count off for aesthetics or whatever. And while traditionally you draw top down, you don't have to. I do always draw top down. Okay, so output, what is the temperature in F? And by the way, guys, I hope nobody's actually typing this part in line by line when you could copy and paste it from your other area. And if you didn't type it in at all, no biggie. All right, what's the next statement? Input F. So I move my mouse close to here. Whoopsie. There. I managed to get a line going from there. Inputs are done in the same tilted rectangles as outputs. Same data block. Well, except this isn't another print. This is input. Input F. If you start making your flowcharts and your pseudocode look more like Python, like if you had put f is equal to input, question mark, excuse me, parentheses, I would not count off. Again, flowcharts are not a programming language. They're designed to help a programmer decide what to do, how to program it. Now, if you put too many language-specific constructs in there, then it's kind of useless to them, because if I was using the C programming language, I wouldn't need that f equals float f statement that I would need whenever I actually go back and write it in Python. There's a reason why I left off that f equals float f line in the pseudocode. If I was going to do it, it would go here after the input f. But not every language needs that. Some languages let you input and directly get the floating point number and not get a string. That makes you convert to a floating point. And so I don't need to be sticking things in a pseudocode that are not applicable to all languages, right? So technical details like converting from strings to floats, I'm not putting in there. All right, we have some math here in this line of code. It kind of annoys me that I have the broken arrow like that. It's not really broken, it's kind of wiggly. I could take some time to fix it, not gonna. So math goes in a pure rectangle. I don't care if you put the word set in there or not. Since I'm mirroring the pseudocode exactly, I may as well. Set C equals, I'm going to go ahead and hit a hard return, a control enter right there, just so I get the rest of the equation all on one line. You don't have to. F minus 32 in parentheses divided by 1.8. Then I need to hook those two boxes up. When I really start to get annoyed with the way these arrows look, I can try lining them up by highlighting them all. This is a drawing program, and you may have used other drawing programs. You can come up here to the toolbar and see if I can find a way to align them. Well, that didn't do the trick. If I right-click and choose Align Center, well, that still didn't do it. And then if I'm really enraged about that broken arrow, I could zoom way in, click on the arrowhead, and I would not take the time to do this on an exam or whatever. If I was taking the time to write this for homework, to be pretty for y'all, I probably would. You can click on a shape and then use the cursor keys to move it around. All right, we've got the temperature in C. Now we have some logic, some a decision to make. If C is less than 0, do something, else do something else. Now those are done with the decision block, diamond. So I'm going to do if, and then I like to try to put the logic on its own line, and so I'm going to hit Control Enter. C is less than 0. I must have turned some auto aligning snap to grid option off since it's not lining things up very well. The book is not going to show the word if there. It's going to be implied. Leave it off if you want. I like putting it in there because it describes exactly what the logic is. Because the diamond can be used to implement more than one logical flow. It can do both loops and if statements. And so I like putting the keyword there. I like putting while or if in there. All right, and so if that is true, we need to output freezing. I tend to always make the true block go off to the right. Why? Because we indent, right? You type if, and then you tab over. Same business. If, tab over. You don't have to do that, right? The arrows could go any which way you wanted to. Yes could go that way, no could go that way, yes could go that way, whatever. I structure these things and I hope that you kind of follow the examples that I give. But as long as the arrows are lining up in the right way, then that's really what matters.
It's just that if you format these, I think, in a way that I do, then it resembles the code more closely. Alrighty, so what kind of shape do I need next? It's going to be an output, and so that needs to be a data block, a tilted rectangle. So this is going to be output, and I'm going to hit Control Enter, quote, freezing, exclamation point, end quote. Notice this word yes. Some textbooks will put the word true rather than yes. Doesn't matter. You know, these things don't even have to be written in English, right? So it's not like the word yes is, you know, set by the Ten Commandments or anything. But we do have to have some indication that that's what's happening there, right? So if this is true, then output freezing. But there's an else. Now, I, as well as all the students who do this, kind of have the urge to put the word else in a block. But there's not an else block. You just make it go off and do whatever's indented under the else. So instead, it's going to say else, and I'm going to choose a tilted rectangle there, and do output, Control Enter, quote, not freezing, end quote.
Now another rule of flowcharting is that whenever the paths diverge, at least at this point of the game, we're going to say that they always have to merge again.
And there's a shape for merging paths. It's called a connector. It's a circle. So I'm going to plop a circle down underneath the if. I'm going to come over here, grab the circle, the connector, drag it. Now it's a huge circle, and it's got an A in it. I kind of would like for you to get rid of the A. Not that I'm going to count off if you don't take the time to do that. And I'm going to draw an arrow from one side going to it, and an arrow from the other side going to it. And I'm going to try to shrink that down a little bit. Right, it's like the "you are here" marker in a mall map being as big as Sears. You know, there's no reason for it to be so large. I don't care if you shrink it or not.
All right, we're practically done. I'm going to add one more statement here that I forgot to put in my original pseudocode.
Above the word stop here, I'm going to do output, quote, done, end quote. Also added an exclamation mark there. I'll go back and modify my original pseudocode with that as well. All right, so I need that statement. So I'm going to draw an arrow down from the circle, do another data block. It's an output, so it needs to be in a tilted rectangle. Output, quote, done.
And then lastly, since we have a start, we need a stop at the end.
All right, a few comments. I'm going to scroll this off temporarily. You'll notice that we have one page here, right? What if you get to the bottom of the page and you need to keep going, right? What if there was a, don't worry, I'll zoom back in a minute. What if there was a shape there and then I need more space? Two things you could do is, one is you could just start a new column, right? So I could, come all the way up here and start a brand new one. I could do that with a line. Or I could even kind of make a, some kind of connector like this. I could go and put a circle. And don't put all this stuff because I'm going to delete it. And here's where the letter's actually useful, right? Because I could make it go A here. And then I could go and put another A up at the top. Right? And then keep drawing from there. And we would know that we were supposed to write. It's kind of like a go-to from here to here. Now, honestly, I wouldn't do that unless I was trying to make it fit on one page. And if I was trying to make it fit on one page, I'd probably do the line version rather than the connector version. If I was y'all, I would just draw a line off the edge of the paper and it automatically adds a second sheet of paper, right? It's okay to make flowcharts that span multiple pages. Okay, so that's our finished flowchart. It'd be cool if we put our name on it. So I'm going to grab the text block, drag it out, put my name, Jeff Thompson. Sure, E, I could put some more information in there. Maybe the date, February 11, 2019, something like that. That'd be pretty. I'd like to see all of that kind of stuff when you draw your flowchart as homework. Take pride in your work. Put your name on it. Now getting fancy. If you wanted to, you could hit Control-A to highlight everything, and then you could change the font. Don't gotta. Matter of fact, I'm really happy with the way it looked. Right. So I'm just going to hit Escape. If you're using Firefox, at least a year ago, Firefox was displaying little black blocks rather than letters in certain cases. And I didn't have a way to fix that. You could try fixing it by changing fonts. You could also try fixing it by switching to Chrome temporarily. Not that I think Chrome's the best browser on the planet, but it is compatible with a lot of websites, so I tend to use it a lot. All right, that is done. Let me wander around and see how y'all are doing. I'm sure that some of y'all already have it done, and some of y'all may be taking time. All right, just a few little more arcane things that are really not important to drawing it. But if you don't like these rectangular lines, you could come up here and choose this thing. And you can say, I want a curved line there. Now, there's absolutely no reason to do that, and you won't see any examples. But I do encourage y'all to play with all the menu options up there, and especially the ones that you can find by right-clicking on something. Especially change shape. That one's important. One that you may wind up doing is arrange, send to back, or send to front. And that would be if for some reason, don't do this, you needed a line that went from there to there, and it was in front of it, but you wanted it to be behind it so that it would look like it would show up, like it was really attached. Then you could check the box that you wanted. You could right-click on the box and do arrange, bring to front, and now it's in front of the line. The only time I use that feature is if I'm in a real hurry. I could draw a series of blocks like this, do something else, do something else, right? I could line up a whole bunch of things, and then I could draw one arrow from the top to the bottom like that. And then I could bring these guys to the front, and then it kind of looks like it's supposed to look. Doesn't have an arrowhead on every block, but that's pretty good. I would understand what was going on there. All right, so we're done with that. My mental memo was to go back and do the output done there. And also I don't need to, but it'd be fun to go ahead and implement this in Python because people like actually getting some code experience under their belts. Wish the theme option was still available. It's got to be somewhere, but I don't see it. All right. When you're ready to save it, do a file save and give it a good name, like Lecture E, you wanted to call it. And then if you were going to submit it to me, like I want you to do, I want you to upload it, you're going to do a file download as. And if you know what file formats are and you have a particular fondness for one, go ahead and grab it. For example, if I was going to paste this into a Word document, I would save it as a PNG. But just as a separate document to upload into the Dropbox, just choose the default, unless you have a reason or a fondness for one of the other ones. So I'm going to choose download as PDF. And then I get this little option over here. I don't care about any of the specialty things. So I'm just going to click download. It asks me where I want to save it. If it doesn't, you can always go and find it anyways. And so I'm going to save it into my CIT folder. Congratulations, you just downloaded your first document. You're well on your way to becoming, okay, great. All right, get rid of that. Now if I click on the PDF to see it, there, right. I'm happy with that, that's it. I could upload that very easily. All right. If you need a printout of this because you didn't finish drawing it, that's cool. I can give you one towards the end of class, or I will also upload it into our daily notes, right? Let's go back to our code. So after that ENDIF in our pseudocode, I wanted to do the word output, quote, done. Now we've seen in previous classes that pretty much every time we did an input F, the very next statement was to convert it to a float if we were going to do math on it, right? If we were typing in somebody's name, then we wouldn't do that. So I didn't put that conversion step here, but when I actually code it, I would. So down here, let's actually do our coding for this program. If you feel like it, you could put a start there and a comment, but just remember that doesn't mean that you have to start tabbing over. That's one of the big differences between pseudocode and actual Python is that you don't tab any of the code to begin with. Right? You don't start off tabbed. Alrighty. And instead of output statements, what do we really use?
Print.
Yep. Print, parentheses, quote. What is the temp in F? Question mark, end quote, in parentheses. Then we need to do the input. F equals input, parentheses, in parentheses. Then we need to convert it. I got a few submissions for homework recently where people did that, and that's not good enough. What does it have to be complete? Right, it has to be F equals. Right. This does a conversion, but unless we store it somewhere, it's a useless conversion. So F equals. Now we have a variable we can play with. Here's our formula. Another difference between Python and pseudocode is the use of the word set. You can leave off the word set and I'll still count the pseudocode correctly, but you better not put it in your Python code or it won't work. So C equals, parentheses, F minus 32, end parentheses, divided by 1.8. Now for my if logic. All if statements have to end in a colon and the next statement after it needs to be tabbed. Pretty much you know that every time you have a tabbed statement, the line above it better have that semicolon. So if C is less than 0, colon, and by the way, you'll see me do this syntax sometimes. I'll put parentheses here. That's just a habit because some other languages require those parentheses to work. Python does not, so I shouldn't put them there. They clutter it up. But they're not wrong. Print parentheses quote. Freezing. End quote. In parentheses. Or, I could expand the text. It's freezing. Whatever, right? Don't capitalize any of these words. If you do that, then it's a syntax error. You get used to spotting those because certain words you expect to be colored in orange if you're using the editor, and if is certainly one of those, else is another. So back tab all the way here, right? Undent it, but then indent the next line. Print, not freezing. End quote, in parentheses. Now I had an ENDIF up here, but there's no such thing as an ENDIF in Python. Well, so why did I put it up here? Because it very carefully delineates the logic here better than leaving it off, right? It's just to help the reader up here. Similarly, I can put an ENDIF right here. I could put ENDIF as a comment if you think it helps the readability. You want to leave it off, if you think it's easier to read like that, that's totally cool as well. I'm waffling on whether I want it there or not. I think I'm going to remove it. And then lastly, we have one more output statement. So print, parentheses, quote, done, end quote, in parentheses. And then a stop comment because it's the end of the program. Now, if I wanted to be cool and awesome and do a good job, get paid for my work, I should be adding comments. Comments could be something like this. Up above the very top print statement, I could do, ask the user for the temperature in F. And then I could put a comment here. Convert from F to C. And then I could do a comment display results. I will post a Python's coding conventions that's going to mention putting comments in your code. It's also totally okay to put the comment, on the same line, right? If the conversion took several lines of code, it would make more sense to have that comment up at the top, like that, right? Because if you had several lines, if it was a complicated conversion, then it makes more sense to have it like that. Display results, since it's not a single print statement, totally cool to go ahead and, do it like kind of a section header. Commenting is a personal style, right? There can be guidelines for recommended practices, but it's also, idiosyncratic personal style thing. I guess I better run it. I'm not sure it works. What is the temperature in F? 100. Not freezing. Whenever you test, and there's an if statement involved, you should test the boundary conditions. We want to test both sides of freezing. Now, unless we know something about Fahrenheit and Celsius, we don't know that 32 degrees is the edge, the boundary between 0 and negative numbers. But we do happen to know that, so I'm going to type in 32. It'd be nice if we printed the temperature right. If we printed out that it was 0 in C. And then I'm going to type in something lower than 32 to see the message it's freezing. And then I'm going to confirm that it crashes if I type in bad input. Right, like that. I can't do anything about it at that time. Now I don't have the knowledge. It can always be particularly vexing if it shows you an error and you're absolutely sure there's no error there. What do I mean by that? Invalid syntax. And you start getting PO'd at it. I know that's spelled right. There's a colon there. It's indented correct. Whenever you cannot spot an error, look on the line above it. In this case, it's the missing parentheses. All right, I will give a homework assignment on this, but I don't want to give it to you yet, or else you'll be working on it to try to finish it during the lecture. So I'm going to leave that alone. All right, so we're doing a little bit fancier stuff in our flowchart than their flowcharts are, just because they're not demonstrating if logic yet. But y'all can handle it, right? Now you know how to do if, so if I ask you to do that in a flowchart, you can do it. All righty, now the textbook mentions mentions loops. A loop is when you have something repeating. So for example, say you had some statement, some calculation for calculating, converting the speed of light from meters to second to miles per hour. And then you were going to do that calculation, for 1,000 different data points. You would not want to copy and paste that formula 1,000 different times. Or you would not want to run the program 1,000 times over and over. Instead, you would create a loop. Whenever you create a loop, you need to avoid creating an infinite loop, which is one that runs forever. I'll give you all an example of an infinite loop, and a piece of logic that we actually will use, although it's not demonstrated in the book. I think that it's okay programming practices that makes it easy to see, but textbooks tend to disagree with me. If I do this, while 1 is less than 2, colon, print fun! Exclamation point, end quote, in parentheses. Fun. All right. It's in an infinite loop. It's not going to do anything else. It's never going to reach the next line of code under here. If I put like another done here or something like that, it's never going to get there. That's an infinite loop. You want to avoid those. I will use that while logic. The fastest, the boiled down to its very, very, very most minimal. While, capital T, true, colon, print quote, loop, end quote, end parentheses. That's an infinite loop boiled down to its hardcore most minimal. But I may actually do while true. But if I do that, there'd better be some way of breaking out of it. And we will learn statements that will break out of a loop. Otherwise, you always actually want to have some code that changes the condition of the loop, right? Because if it's based on some condition, like while temperature greater than 72 degrees, keep the air conditioning on, something better change that temperature, or else the air conditioner is going to go on forever. Let's go ahead and write an example of a loop, just for fun. X is equal to 1. While x is less than or equal to 10, colon, print, parentheses, x, into parentheses. And then x equals x plus 1, which I could abbreviate as x plus equals 1. All right, now that's a loop, and it's going to repeat that code. But it's not going to run forever, right? Because the condition starts off true, but eventually x increases to the point where it is no longer less than 10. And the textbook will show you a way to flowchart it, and I flowchart it in a different way. Either way is correct. I'm going to skip flowcharting it for now. repeating instructions. Input my number. My answer is equal to my number times 2. Output my answer. Input my number. My answer equals my number times 2. Output my answer. Input my number. My answer is equal to my number times 2. Output my answer, and repeat 10,000 times. This is stupid. You would not do that. Instead, you would write a loop. Now, this is a dumb loop. It's a loop that we could not code in Python in this fashion. It requires the use of what's known as a goto statement. Python doesn't have a goto statement that works. Gotos are considered extraordinarily poor programming, and most languages invented after like 1980 don't have them. Then we don't go into any further about how to really do it, so we will skip flowcharting. Just know that that's not how to flowchart a loop. We'll see the right way later. Using a sentinel value to end a program. This would be worth doing. It'll be probably the last little bit of programming we do today. A sentinel value is when you ask the user for a piece of data, but you give them the option of quitting the program at the same time. Right. You're letting the user enter test scores to average all the test scores. Enter test score, or -1 to quit. Right, so they type in 90, and then it says that again. Enter test score, -1 to quit. They type 80, hit enter. They type in 100, hit enter. And then finally they get tired of entering test scores and they hit -1. That's called a sentinel value. Right, a sentinel standing there is not letting any people into the loop anymore. You type in that -1, stops, skips the loop. So that's known as a sentinel value. You could consider it a dummy value because the user would never, hopefully your teacher's not a jerk to give you a -1 on a quiz. A sentinel value could also be like an end of file marker in a file. You open a file and you're reading all the data to the very end. So let's add a little bit of code to our program, and it'll be the last thing we do. So here's what I'm going to do. I'm going to do this. X is equal to 1, and then while x is greater than or equal to 0, we're going to ask the user for a new value of x, and then we're going to print it out, something like that. But we need to tell the user that they can type in -1 to quit the program. So, print, parentheses, quote, enter a test score, or -1 to stop, parentheses, in parentheses. Then we better get our input. I'm going to do this I'll do it not the shortcut way. X equals input, parentheses, in parentheses. And then x equals float, parentheses, x. If x is greater than or equal to 0, let's do something. We could add it to a series of scores. I'm just going to print out thanks. And I'm going to remove those parentheses. See, I defaulted to using syntax for another one. Nope, in this language they're necessary. Prints always have to have parentheses after them. Print, parentheses, quote, thanks, in parentheses. All right, and then after that, I'm going to print out one final done message. Print, parentheses, quote, done. And we will see the way it works is that a value of less than -1 or -1 or whatever is going to be our stopping point. Enter a test score or -1 to stop. 100, 200, 300, -1, it stops. I'm going to change this from greater than or equal to 0 to not equal -1. I'm going to check very specifically for our syntax value. Then I'm going to stop messing with it. So if x not equal, not being an exclamation point equals -1. And I'm just going to put a comment down here. -1 is our sentinel value that exits the loop. Alright guys, I believe there's a Dropbox E. So if you'd be so kind, go ahead and upload your flowchart. Also upload these notes if you want. So let me come up with some homework for y'all. Alright, so that's the homework. I want you to draw a flowchart for this logic. Input X, input Y. Be nice to tell the user what to do. I don't care if you put extra print statements or if you just do those two things, right? And then if Y is equal to 0, output cannot divide by 0, right? Because you can't divide by 0, it would be an error. Else result equals X divided by Y, output result. I'm going to put a set statement in front of that result. I'll go ahead and put the print statements here. Output, quote, enter X, and then output, quote. And you never need to type in the homework because I always upload it. But if you feel like typing in every single thing I have, that's fine. And you know where the Dropbox is. The Dropbox is there, I really hope. If you take a quiz and then you happen to go into the grade section and you don't see a grade for your quiz, let me know. And as a matter of fact, I'm going to make a Dropbox called Grade Corrections to where you can upload a complaint about a grade. So if you ever see a grade that's missing, just upload a note to the Grade Corrections. That way we'll have a permanent record of it. It'll be easy to go back and refer to. Now, what kind of grade correction? What if I say, great job, but I give you a 0? You need a grade correction. You do something in Mind Tap, but you check the grades here and you don't see a grade. That's another problem. Let me know. All right, gang, any questions? Nope. All right, we're done. I'll take roll based on what you upload today.